the last section in chapter 7, which has dealt with exponents and polynomials. In today's lesson, we're going to be taking a look at special products of binomials. Now remember, a binomial is simply a polynomial that has two terms, such as x plus 3 or x plus 4. We're going to be looking at some patterns that help us to find these special products more quickly. First, we're going to take a look at something called a perfect square trinomial. Now think about the phrase perfect square trinomial. A perfect square trinomial is a trinomial, meaning it has three terms, that is the result of squaring a binomial. Now I've shown you four examples here. Let's look at the patterns. We have x plus 3, the binomial x plus 3 squared. We have the binomial x plus 4 squared, the binomial x plus 5 squared, and then we have the general form of the binomial a plus b squared. Looking at the patterns here, we know that when we square a binomial, we simply multiply it by itself. Now you can use FOIL to find your product. Remember, FOIL is multiplying the first terms. X times x is x squared. The outside terms, which in this case 3 times x or 3x, the inside terms 3 times x or 3x, and then the last two terms 3 times 3 or 9. The product for the perfect square binomial, the perfect square trinomial x plus 3 squared is x squared plus 6x plus 9. Again, looking at patterns, when we square x plus 4, we get x squared plus 8x plus 16. The square of x plus 5 is x squared plus 10x plus 25. Let's look at the patterns to see if we can find our special products without using FOIL. For each of these examples, notice the very first term is simply the square of the first term in our binomial. So for example, x plus 3, the quantity squared, our first term is x squared. X plus 4, the quantity squared, our first term is x squared. X plus 5, again, the first term is x squared. In general, whenever you square a binomial, the very first term of your trinomial will be that first term squared, a squared in this example. For each of these examples, look at the middle term. X plus 3, the quantity squared, we get 6x for our middle term. For x plus 4, the quantity squared, we get 8x for the middle term. For the square of the binomial x plus 5, we get 10x. Notice in each of these cases, that middle term is simply the first term times the last term doubled. So we get 6x because 3 times x is 3x, double is 6x. We get 8x for our second one because 4 times x is 4x, double it, you get 8x. For 5x plus 5, 5 times x is 5x, double it, you get 10x. In general, when you have a binomial squared, the middle term will always be the first times the last double. So in this case, the middle term is 2ab. The last term of our trinomial is simply found by squaring the last term of the binomial. So for the first one, you square 3 to get 9. For the second one, you square 4 to get 16. For the last one, you square 5 to get 25. And in general, you square the last term b to get your b squared. These are the patterns. Now let's try some examples. Let's see if you can predict what the trinomial will be for x plus 7, the quantity squared. We square the first term to get our x squared. And then we're going to double or multiply times 2 the first term times the second term. So that's 2 times 7 times x. And then we square our last term. Our last term is a 7. 7 squared is 49. So this trinomial squared is x squared plus 14x plus 49. We have the first term, that's the square of x. The last term is the square of 7. The middle term is 2 times 7 times x. can do the same thing with other variables. In this example, we have 4s plus 3t squared. We're going to square that first term. The first term is 4s. When you square 4s, you get 4s times 4s is 16s squared. Then we multiply the first term times the second term. So we have 4s times 4t. But remember, you have to double it. So that becomes 2 times 4s times 4t. And then for the last term, we have to square the last term in our binomial. 4t times 4t is 16t squared. Now let's simplify our binomial. We get 16s squared. 2 times 4 times 4 is 32. So plus 32 times s times t plus 16t squared. One more example of that type. We have our number in front followed by our variable. We're going to square our first term. This is a 5. 5 times 5 is 25 plus 2 times the first term times the last term. So that's 2 times 5 times m squared plus m squared to the second power. Let's simplify. Now we have 25 plus 2 times 5 is 10 m squared plus, remember, m squared to the second power becomes m to the fourth. Here's our perfect square trinomial. Let's see what happens when we have a binomial where we subtract. In the second level of examples, we have the first term minus the second term. But we'll use the same pattern. The first term squared would be x squared. Minus instead of plus because we're subtracting. So minus 2 times 6 times x. And then for our last term, because we're multiplying negative 6 times negative 6, we get a plus or a positive 36. When we simplify, that gives us x squared minus 12x plus 36. For part B, example B, 4m squared, or 4m minus 10 squared. Let's see if we can take a step out. Our first term squared would be 16m squared. Let's see if you can do this in your head. We're going to double 4m times 10. 4m times 10 is 40. When you double it, you get 80m. But remember, it's minus because there's a minus sign in the binomial. Our last term will be negative 10 times negative 10, which is a positive 100. Our answer is 16m squared minus 80m plus 100. 2x minus 5y squared. Again, let's try to do this in one step. 2x times 2x is 4x squared. We just squared our first term. We're going to double. 2 times 5 is 10xy. So we get double that would be 20xy. So that's minus 20xy. We got that by multiplying 2 times 2x times 5y. Again, 2 times 2 is 4 times 5 is 20. Multiply it all together, we get 20xy. And then negative 5y times negative 5y is a positive 25y squared. One more example. See if you can follow along and predict what the answer will be. 7 minus r cubed squared. When we square the first term is 7. When we square it, we get 49. Minus, because we have a minus sign, 7 times r cubed is 7r cubed. But when you double it, you get 14r cubed. Plus, negative r cubed times negative r cubed is a positive r to the 6th. This is how we square a binomial when we have a subtraction sign. That's the first type of special product. And we're going to look at the difference of two squares. Again, look at the name, difference. That means we're going to be subtracting. Difference of two squares. That means we're going to have one square minus another. The difference of two squares looks like this. A squared minus B squared. So we have, again, I'm going to label this difference because we're subtracting. We have, here's one square. There's another square, so we have two squares. How do we get this product? This is the answer we get as a result of multiplying this type of binomial. Example 3, level A, let's say we're multiplying x plus 4 times x minus 4. Now we can use FOIL to get our answer, but let's look at the pattern. Using FOIL, we're going to multiply our first terms together. X times x is x squared. We're going to multiply the outside terms, so we have a negative 4 times x, which is negative 4x. And we're going to multiply together the inside terms. The inside terms are 4 times x, or plus 4x. And then we do our last two terms, which is 4 times negative 4, or negative 16. Now, when we simplify this product, we'll be combining the like terms negative 4x plus 4x. But negative 4x and plus 4x are opposites, so their sum is 0. When we simplify this, however, we get a difference of two squares. If you know the form of the special product, you can write the answer or the product simply by looking at the problem. How do you recognize this type of problem? This is what you get when you have two binomials where the terms are the same, but one has an addition sign and one has a subtraction sign. So here's another example. The two terms, p squared and 8q, are the same, but in the first binomial, we're adding, and the second binomial, we're subtracting. When that's the case, you simply square the first term, which is p squared. When you square p to the second power, you get p to the fourth power. The middle two terms drop out because they're opposites, and the last term, therefore, is the last term squared. 8q times 8q is 64q squared. But since we're multiplying a positive times a negative, we get 64q squared. We get minus 64q squared. One more example of this type. 10 plus b times 10 minus b. Looking at the pattern, I know I'm going to square the first term. This first term is 10. When you square 10, you get 100. I'm going to put a minus sign in the middle, and I'm going to square the last term. The last term is a b. b times b is b squared, and I am done. Went very quickly because I used the pattern. Let's look at a word problem, an application problem. I have a yard, and in this yard I have a pool. I want to find the area of the yard around the pool. Well, we're going to use algebra to solve this problem, so instead of giving a specific length, we're going to call each side length x plus 5. We're going to call the area of the pool, one side we're going to call x minus 2, and the other side is x plus 2. How do we find the area of the yard around the pool? The area of the yard around the pool will be the area of the total, which is x plus 5 squared minus the area of the pool, which is x plus 2 times x minus 2. Let's use our knowledge of special products to find our answer. First, let's do the perfect square trinomial. Remember, we will square the first term. The middle term will be double the first term times the last term, so double 5 times x, we get 10x. And then our last term will be 5 times 5, or 25. This is the total area. The area of the pool is our special difference of two squares. So x plus 2 times x minus 2, I know the pattern. I'll square the first term and subtract, that middle term cancels, subtract 2 times negative 2, which is 4. If I'm subtracting that, if I'm subtracting this whole thing, remember, we just finished adding polynomials. Remember that when you're subtracting, you change everything inside to the opposite. So this positive x squared becomes a minus. This minus 4 becomes a plus 4. And now I'm adding the two together. X squared minus x squared, this goes away. And then I have a 10x plus 29, which represents the area of my pool. That's all for today, and that's all of chapter 7. Thank you.